This is a brief review of a few fundamental derivatives we'll need to be able to do in our course. Let's start with the simplest sort of function we could look at. Let's suppose we have a polynomial function, 7x to the third plus 5x squared minus 3x plus 1. And let's suppose that we want to do the derivative of this function. Recall that we have a couple notations for derivative. One would be y prime. Of course, that's the easiest thing to write, and so a lot of us will favor that. But one unfortunate thing is that indicates to us that y is the dependent variable, but it doesn't tell us the independent variable. So if we use the other notation called Leibniz notation, dy dx, tells us we're doing the derivative of y with respect to x. Y is the dependent variable, x is the independent variable. And you'll recall that to do the derivative of a function like this, we simply need to take each exponent and multiply it by the coefficient of that power of x and decrease the exponent by 1. So here we'd have 3 times 7 is 21. The power of x goes from third down to second. Over here, 2 times 5 is 10, so we have plus 10. Power goes from 2 down to 1, so that's x to the first, which is just x. Over here, we take our exponent, which is understood to be 1. 1 times negative 3 is negative 3. The power of x goes down to the 0 power, and x to the 0 is just 1. So anytime we have a constant times x, the derivative is just that constant. And then over here, the derivative of a constant is 0, so the derivative of that 1 is 0. So that again is how we do the derivative of a polynomial function. Another variety of function that we're going to run into quite commonly, more often than these in fact, is an exponential function. So suppose we have an exponential function like 3.1 times e to the minus 0.4 t. Okay, and we want to do the derivative of this, so we want to find dy dt. And what happens in this case is the following. I'm going to show an extra step that we probably won't normally show. Let's leave the constant alone. The derivative of e to a power is still e to the very same power. But then what we have to do is take that power itself, the negative 0.4t, and take its derivative and multiply it on. By not putting any symbol here, I've indicated that this is a multiplication. And of course, the derivative of negative 0.4t is just negative 0.4. So we end up here with a negative 0.4 that we can then multiply by this 3.1. So dy dt is then negative 0.4 times 3.1. Let me use my calculator to get that. So 0.4 times 3.1 equals 1.24, but it's negative, so we have negative 1.24 e to the minus 0.4 t. Now this is the chain rule here that we're using. Here's the formula sheet that you'll be allowed to use in this class for quizzes and exams. And if we flip it to the back side, there's some basic derivatives. And the rule that we're using here is this one, the derivative of e to a power. Let me see if we can get both of those on there at once. Looks like we'll barely make it. The derivative of e to a power is e to that same power times the derivative of the power. So here, the derivative of e to the minus 0.4t is e to the minus 0.4t times the derivative of negative 0.4t. And here's the more specific rule we're actually using in this case. E to a constant times a variable is the constant times e to the constant times a variable. So feel free to make use of this as you need it to calculate derivatives in our course. The one last derivative I'd like to do in this particular section is, let's suppose we have something like x. X can actually be our independent variable, or excuse me, our dependent. You're used to it as an independent variable. But let's say that x equals 4.7 cosine of, say, 2.1 t. Okay, so we want to do the derivative of this, and let's see. We remember that the derivatives of sine and cosine are each other, and so the derivative of cosine is sine. But wait a minute, let's see. Let's look on our sheet here. The derivative of cosine is actually negative sine. So when we do the derivative of this cosine, we'll get negative sine of the same thing. The u doesn't change, but we have to multiply by the derivative of the u. So in this case, when we go to find dx dt, again, this constant just stays there. It's multiplied on. And then the derivative of cosine is negative sine. Let me put a parenthesis here to indicate that we're multiplying. We're not subtracting. So it's 4.7 times negative sine of 2.1t. And then we need the derivative of the 2.1t, which is, of course, 2.1. So when we get all done, what we're going to have is we'll take the 2.1 from here and multiply it by the 4.7, but we're also multiplying by a negative. So we have negative 4.7 times 2.1. 4.7 times 2.1 is 9.87, so we get negative 9.87 times the sine of 2.1t. Notice that whatever we're doing the sine or cosine of our original function, in this case it's cosine of 2.1t, shows up in our derivative as well. That never changes. Just like up here, when we're doing a derivative of e to a power, our final result will still have e to the very same power in it. All right, so let's take a pause and we'll come back and review the product rule.